So we're at HAVN's lab in Taiwan. We're here just ahead of Computex, and HAVN was experimenting with this fan. This is a 52 millimeter thick fan. Now this isn't what ended up going in the case that we're looking at today. This is what went in there. And so we've got details on the new case, which is behind me here. This is a mock-up version, one of the later mock-ups. This is a BF360 it's called. We'll talk about that today. It's following up their HS420. And then the fans get a special focus as well because they've done a lot of, as they describe it, careful shaping to things like you can see the light reflect off the hub there. That's supposed to help with guiding the flow. Obviously, testing, we'll have to look at how it performs, but the idea is taking a thicker fan approach, except thickening it even more. This is a 40 millimeter thick fan, which should help with things like pressure. This is a 180 mil fan, and what they're doing is mounting two of these in the front of these new cases. HAVN has prepared some CFD simulations for the flow, but then they also have some simulations for mechanical stresses, which is pretty interesting. So on the panel, for example, the case that people know is this one. This is the HS420. We reviewed this overall pretty positively. This one, as a reminder, it's got that curved glass in the floor tray. The thing they're working on now is the BF360 here. Before that, this video is brought to you by Thermalright and the Frozen Prism 360 liquid cooler. Thermalright's Frozen Prism is one of the most affordable liquid coolers on the market and is able to achieve competitive results with a high cold plate convexity that applies pressure centrally to the silicon area based on our testing. This works on both AMD and Intel. We previously benchmarked the Frozen Prism and found that it's overall competitive for its price point. The cooler comes in a few color variations. It has a blackout option and an RGB option, and it's the cheapest liquid cooler we've tested anytime recently that still hits performance markers. Learn more at the link in the description below. All right, so this is the BF360. This case, we'll just pull it apart first. Front panel pops out like that. It's got a magnet in it. It snaps, sort of sockets in with those three plastic feet at the bottom. And the interior of the front panel has this fan tray. So this is somewhat typical, but refined from what we've seen. They've done a lot of iterations of this we'll look at in the design process. That's the tray though. Top panel pulls off, and this is familiar to the HS420 and sort of the structural and design, if you're used to that. This actually has a really nice slide mechanism because it's got these rubber bumpers everywhere. So there's two rubber sort of feet in the back and then two up here on the sides. So this slides out like that when the screws are not in it, which they're not right now. So that removes, exposes basically full access through the top panel here, which should help with ease of installation. So a lot of the steel in this case is either 0.8 millimeters or some that's 1.0, which is thick by today's standards for 1.0. Backside, so on the HS420, one of the things we liked was that they had marked cable management pathways with stickers and had suggestions, which is kind of like a nice thing for brand new system builders. They've done that again, but built it into the molding. My understanding is they're going to potentially refine this to try and get some more light reflection, maybe a deeper groove or something so it's easier to see. This is a nice attention to detail, like ease of installation feature. From the HS420, they've also kind of learned on the 3.5-inch drive support and improved that. There's two bays here for those. This whole panel also pulls out, so it pops up and removes. There are also changes to the way these grommets are done. So this part is the same, where it's like the sort of strain-like material in between. But internally, we'll come over here to some of the mock-ups. The change is on these now, there's basically a little tab right there. So you can see that sort of that nub in the rubber that helps to prevent it from popping out by accident once it's filled with cables. The point being, I guess, HAVN is trying to learn from what they've done with the HS420 and refine it. And for the rest of the BF360, so first of all, the front panel, this is supposed to look like stone. It is not. That would be extremely heavy. It's plastic. And then behind it, the one with the fan, so these are two 180s. What they've done here is shoved in this piece of steel at the top, and that is to prevent recirculation. So in the old BitPhoenix cases, this was a huge issue they had back in the day, where BitPhoenix would put fans in the front, and then because of the way they spaced the fans out with the rest of the panel, they would have hot air recirculate back into those very fans. So this can actually improve performance in big ways. What's interesting though with this layout, they're saying the best setup in their testing, HAVN's, is intake in the front here, exhaust in the back here, if it's 180s in the top. And that matches our testing for other cases in the past. So we have also found that if you're populating the top slots doing an intake in front of an air cooler works better. That's just because otherwise the air goes in the front, and if this is exhaust, it gets stolen, comes out the top. So this is a 4-180 setup. The stock setup is supposed to be 2 180s front, 140 rear. So they've tried all these different types of shroud for the power supply shroud, where it's got the angled scoop to bring air in from that bottom 180. So this one is like sort of that toilet bowl design we've seen in some of the other cases on the market. That didn't go through. This one is a more cylindrical or conical design. And talking with one of the thermal engineers, I was asking, why did this one not work better? Because you kind of look at it, and the theory is that it just directs the air and more forcefully centers it and projects it straight into the back part of the GPU, which would be where the actual GPU is, the hotspot. They were saying that going with a wider design like this one ended up just thermally performing better. And so we've got some numbers for that too, but we'll do our own testing if we can get me one of the earlier samples. This mock-up, this is the first mock-up. So this one has these rails in here for the fans. These did not end up progressing into the final. So this is a rails system. You've seen these in other cases. Corsair does it. They have a trademark and everything. They've called it the InfiniRail, TM. But that is something that we've seen before. This is also rails. This is mock-up 2. They moved to vertical rails on this one, and then it would slat across still. Actually, they're right here with these. They ended up ditching this altogether, moving to this design, which you can see is moving towards that tray that we've seen in cases in the past. So it's kind of like going to the tried and true approach of things. This is another change to it, where now they've stamped and folded. They fold this one more time here with the tooling, and then over here is closer to final. So you can see it's got the sort of full corner covered now. So just some cool design iteration stuff with the mock-ups. We normally don't get to see a whole lot of that. We tend to just see whatever the final product is. For other things, so over here, there's different panel types. These are not what's included on the final. So the final ended up using that sort of stone-looking black and white models. This is a wood panel. Obviously, we've seen these on a lot of cases lately. Wood has certain challenges manufacturing. This is an aluminum panel, which is just very expensive. All right, then the last thing they're working on, so this is really interesting to me, is the fans. There's been a lot of development in fans the last couple of years. It's become marketing, but there is value to it. So one of the phrases you hear a lot now is LCP. This is something we talked about a lot at the last Computex. Benefits of LCP, which this is not, but benefits of it are that you can get the blades way closer to the frame, the interior of the frame, which can help with the performance. The downside is it is incredibly expensive. And so we actually had a whole separate interview with Noctua, I think 2 years ago. It's a really good interview you should listen to, where one of the technical people over there, Jacob Dellinger, talks about how they basically spent years and years and years trying to not use LCP. And then they ended up having to use it for the performance they wanted. So this is not using that. This is, I think it's a PBT, and then it's a 30% like fiberglass or something. But this is the new fan design that HAVN's doing. So we got some time to speak with their thermal engineer, and the key things they're focusing on in terms of what they say helps improve the performance the most. We obviously haven't tested it first party yet, but is cutting these teeth into the front. We have seen this in the past. They've also shaped the hub, like you see here, to try and scoop the air in more. Now, apparently, doing just like a straight up cone coming out of here, like protruding like a mountain from this, is the best performance, but then you run into clearance issues and compatibility problems, and especially if you want to put like a radiator and do a pole or something. So they chopped it down and did this as a compromise. For the blade distance to the frame, so the 180 is pretty interesting, where this is a 2.0 millimeter distance from the frame. And I asked, well, did you try closer or not? And so the information we got, this is a 1.8, this is a 2.0, this is a 2.2. And this is for the 180 by 40 thickness. That's that 40 is. What they ended up seeing was that for the pressure, so millimeters aqua here, or millimeters H2O if you prefer, 2.0 ran at 2.19, and then 1.8 ran at 2.23, which is an improvement. CFM was at 165, basically 165. This is like indistinguishable more or less. And then this, there was a big drop off. So 2.2, which they did not go with, that is running at a 2.21 for the millimeters pressure, which is actually more or less within air. And then the 160s where that drop off occurs in the CFM. And then they also have some noise levels as well. So the interesting thing here, I guess, is between 2.0 and 1.8, they're basically hitting diminishing returns. And the reason I like seeing this kind of data is because a lot of times companies don't want to show something where it's like, well, there is a better one, but we didn't use it. And they're showing that here. It's just that the benefit of it in this testing, I would imagine, was just not worth the yields and the costs, because getting that blade closer to the inner frame, especially without a material that doesn't deform as much with like LCP, the closer it is to that frame, the higher the risk is of either a bad yield in manufacturing or just aging with time. It'll kind of expand and start clipping the frame, which happened to a lot of Enermax fans in the past. So anyway, we'll go through some of this data. I need to write that up because they have a whole slideshow. We're going to talk about that for the rest of this video, and then we'll come back here. All right, so we'll go over some of HAVN's first-party numbers now. We'll do our own performance review of the case and the fans once they're available. This is their first-party data, which should always be taken with some reasonable care. Thermal comparisons should only be made against their own results here, not against ours. Our benches are different, so you can't take these numbers and compare it to our charts. But the flat and typical Shroud style that they compared was similar to the rectangular type in result, with the rectangular type slightly better. We think this will see a larger impact in our testing if we were to have the 3 Shrouds, but the important conclusion they had was that the cylindrical type, where HAVN had worse results by a measurable amount, was the one they decided not to go with despite trying it out. Performance worsened by 1 to 2 degrees on the CPU and about 2 degrees on the GPU, which is actually a large GPU temperature increase. In their next test slide, HAVN tested various fan configurations with the flat Shroud. The results were mostly expected. CPU performance is hurt drastically by having only a bottom intake fan, to no surprise. And more interesting, the ramp type Shroud makes comparisons in B, shown here, with a fan level with the top of it, and A, with the fan sunken to the floor of the ramp. The sunken approach resulted in marginally worse CPU thermals in A as compared to B, with GPU thermals mostly unchanged. This slide shows CFD simulation and flow mapping for ramp angles at 120 and 135 degrees. HAVN has drawn a few highlights around areas of recirculation or heat accumulation, particularly marked at 1, where the 120-degree ramp angle shows worse areas of heat buildup. And then HAVN also tested this in 5-degree increments from 120 to 140, finding that 135 was a good balance when noise normalized. In this image, they show the fan spacing again, with a 20mm height increase benefiting the performance. HAVN didn't shy away from competitive comparisons here. The company says that its BF360, with its final front panel shown in light blue, had competitive performance against the H6, and they also suggest significant reductions in flow resistance, which is a good thing, versus the Landcool 3, with the HS420 also making some appearances here. HAVN began studying its slot spacing and porosity of the ventilation slots in the panels next. The company found that the ratio of length divided by depth being ideally equal to about 6 was optimal for minimizing flow resistance, with the only downside being potential structural challenges. So these charts show their flow performance with the different slot sizes. As shown in this set of images, the point is that HAVN is really mocking up a ton of different style of panels, from the Shrouds to the slot spacing, to try and determine the thermal performance and optimize for it. So this is a major progression from them. It's a lot of work to do all this, which is cool to see. Of course, we have to test the real product and see how it actually came together, but the CFM performance of Type 4, as they called it, was the best in this image, and ultimately we're looking at pretty tiny differences here. It's just that all those small differences, in theory, will add up across the case. This image was cool. So after all the thermal testing, HAVN next showed mechanical stress simulation for torsional forces against the panel, which allowed them to dial in the thickness and the makeup of the plastics. That continued in this image, where the so-called Type 4 panel gets another highlight. HAVN highlighted so-called Design C for having a 0.8mm metal thickness with the chosen hole sizing. So by shaping the fan hub to guide the flow, HAVN claims that it can better maintain pressure across the hub of the fan and along the inner wall of the blades. This is the area of worst performance in every fan, so optimizing here can help minimize dead zones behind the hub. HAVN says that the molded flow guide in the fan here for the hub benefited its noise significantly, and it claims that the flow rate also improved significantly for the guided hub. This image is also pretty cool. Referencing whale fin evolution, HAVN used tooth-like leading edges on the fan to improve its thermal performance. We've seen this plenty of times in the past. Sometimes companies reference biomimetics, but either way, it never seems to really stick around. We're not too sure why. In this simulation, though, HAVN suggests that the airstream is more uniform along the wavy blade design. Using a 30% glass fiber composite, HAVN saw performance with the new design slightly improve in CFM, but largely improve in static pressure, going from 2.21 to 2.40 millimeters H2O. There's a ton more that HAVN did. This PQ chart, for example, shows mock-up performance, including the stall region centrally. We'll save all this discussion for the review, though. They had 41 pages of technical presentation, which is actually greatly appreciated. A lot of that will be covered in our review, so we'll leave the rest of that for then. The bearings are interesting to talk about. So these are FDBs, or at least so-called, depending on how you want to define that. This is for the 180 mil fan. So this is a 15 millimeter tall FDB. So one of the things with fans, in terms of the support, is how this rod seats into the bearing. So if you had a bearing like this, it'll kind of sit in there, and we have a whole bearing factory tour if you want to see it. But as I'm told, the longer the bearing is, the more it'll help with kind of the wobble of the blade, and so it should help to stabilize its spin if it's got a longer bearing to sit inside of. So that's part of the reason. Now, the other thing they were showing us is cross-sectioning these, where internally here, this is the 15 mil tall one for the 180, there are 3 grooved channels. And actually in our TPI bearing factory tour, we talked about this with them, where the grooves are part of the mechanism that allows the fluid to circulate and kind of keep that pressure even across the bearing. So we've got a whole video on that, but that's supposed to be what's special about this one. I mean, we don't test bearings individually. I couldn't tell you, but the idea is that 3 channels is supposed to help with the sort of the stability of the fluid across the bearing. The other difference is in the 120s, HAVN's going for a roughly 12 millimeter tall bearing, whereas they tell us, and I have not cut open fans to cross-section it myself, but the claim is that typically they are 9 to 10 or 11 millimeters tall, with 11 being this one here for 120 millimeter fans. So that's kind of the concept for the fans. For their setup, so first of all, walked in the room and I found something I recognized. Now this is not, we do overclock the GPU, to be fair to them. I don't think we have the public numbers on that out there, but it's a pretty close guess. So they're doing some comparison to try and figure out how the cases will perform, I think, in our own testing once we post the reviews, which I will say I'm flattered by. Thank you. This is a chamber, so this is a thermal chamber. There's pros and cons to testing with these. The pro is that it's supposed to help control the thermal environment. I'll talk about that more once I close it. What they're doing though is they're circulating the air through, running the new case for testing. This is the BF360 that they're running tests on. It's got 2 180s in the front. It has one 140 in the back, and they're running a heat load on it. Let's close this chamber to get the noise levels back down. Downsides to the chambers is we found they can influence the results. It really depends on the chamber. So long story short, we found that for our testing specifically, having a larger open room environment works better. It is very environment specific, so we're not going to get into that topic today, but they're running a chamber for that test, which is cool to see. This, I recognize, is a different version of what we have. So this is a flow rate tester. It can do PQ charts, and what they're doing is testing the new fans on it. So this is a long wind chamber. They have the throttle control. This is a laser tachometer up here. So this hooks up, and it can read the speed of the fan. This is just a DC power supply, it's a benchtop power supply. And then basically on the front here, just like with ours, you mount the fan. So they've got the 180 mil currently mounted, and then all the different valves that open and close are in here. It's like the same concept as our chamber, just reoriented a little bit. This is all the controls for the different nozzles. And then back here, they've got the setup where it's just the tubes for the counter blowers. There's a giant counter blower fan under there, just like with ours. That's their air compressor, which is used for actuating some of the nozzles and things inside the system. And then just like ours, their, I'm sure, very expensive fan testing machine comes with a very not expensive desktop OEM computer. And I am just curious. Yes, they got an i5 12400. So that might actually be an upgrade over the one we have. I don't remember. They're not particularly high end. So the last thing in this room is this acoustic chamber. This I recognized right away because we also innovated with a piece of wood. Ours is round, so it is mechanically superior, but this will do. That's to measure distance. This is the acoustic chamber. So they're doing a pass through here. This is their meter for collecting the noise levels. And then basically on the inside of the chamber here, Actually, the thing I like the most is that mechanical rigging for the fan. So they're suspending the fan to be as sort of free flow as they can, and then the microphone is in the corner there, which we used to do this when we had a chamber of this size as well, where that allows you to maximize the distance of the chamber by going diagonal, so you can do maybe half a meter or something like that to adjust and account for the distance loss you would have from a bigger chamber. And then they've got actually the foam floor as well. So this is closer to an anechoic chamber rather than a hemi-anechoic chamber, and it's used for acoustic testing. But anyway, that is the HAVN Lab. Pretty cool to see all this stuff broken out like that. We're definitely gonna have a lot more to talk about when the reviews come around. So as a reminder for everyone, we are out here for Computex, which means it's gonna be news all week. It's gonna be probably a couple weeks of news. And then we'll start getting the stuff into review as it launches. So launch for this is supposed to be somewhere around September, at which point we will be able to benchmark it, let you all know how it performs. But otherwise, that's it for this one. Check back for the rest of the news the next couple weeks. And we've got a lot of cool technical interviews coming up as well. So subscribe for more. You can go to store.gamersnexus.net or patreon.com/gamersnexus to help us out directly, like with these trips. And we'll see you all next time.